And we're going to talk today about what's called synthetic division. And synthetic division gives us the exact same answers as long division, but it is it's done in a much faster, more economical way. Okay, so the way we do synthetic division is first we must have a linear factor. Okay, if you do not have a linear factor that you are dividing with, the divisor right here has to be linear. If it is not linear, then you must do long division. But if it is linear, like today will be all linear, then we are going to work on these problems with synthetic division. And to use synthetic division, it looks a little bit different. Okay, but what you are going to do is you are going to first find the root. So if x minus 3 is the factor we're dividing with, then x equals 3 is my root. We're going to come over here and put a 3 on the side. And we're going to do an upside down. Sometimes synthetic division is called upside down division because the bar that you divide with is not the normal one, it's upside down. So we're going to write like an L shape here. And now we come over here to our dividend, and we only use the coefficients. Okay, so this is a 1 coefficient for x squared, -7 coefficient for x, and 12 coefficient for the constant. Okay, under the constant, we're going to put a little box, and this little box is where your remainder will go. And it's shielded for a reason. I'll show you why that's the case in just a second. Okay, to do synthetic division, what we do is we bring down the first term, whatever this digit is right here. We're just going to bring that down, and all our answers are going to be written down here on the bottom. We bring that down and put a 1. And whatever this is, that's what you write down. If it's a 5, you put a 5, etc. You multiply like before. So we multiply on the outsides. 3 times 1 makes 3. You write it in the next column. And now you add the column. Do not subtract with synthetic division. You add the column. So -7 plus 3 makes -4. And then you repeat the process. -4 times 3 is -12. And you write the remainder in the box. Okay? So this is not the answer for synthetic division. This is how we found the answer for using synthetic division. So we have to recode this now. So originally the dividend, this was the x squared column, this was the x column, and this is the constant column. Our answers are all 1 power, 1 degree less. And the reason is because we divided out a linear factor. An x squared divided by an x makes an x. So this refers to 1x. If we had an x column here, we divide it out with an x. So this is now the constant column. And this would be your remainder. We would still write the remainder as a fraction, right? So in essence, if this was a number here, I'll just put it plus the remainder out of whatever you were dividing with, x minus 3. In this case, we don't need to worry about that. Okay, so our correct answer here, when we did division, is x minus 4. And that's how you do synthetic division. It is a much faster way than long division. Okay, we're going to do one more example here. I'm going to do example number, let's do number 5 here. Okay, on number 5, we have a linear factor again. That tells me I can do synthetic division, but we must find the root again. So if you find the root, you set it equal to 0, we're going to add 5 and divide by 2. So that tells me that x would be 5 over 2. So we're going to use 5 over 2 as our root to use synthetic division, and we're going to now write all of our terms, our coefficients of each term. We have 2x to the fourths, we have -5x cubes, we have -8x squareds, we have 4x's, and we have -12. By the way, make sure that if you ever have a term that's missing, that you put a placeholder. For example, on number 8, I don't see any x's right here. So make sure you put 0 in the x column. Otherwise, you will mess up the synthetic division. Okay, under the constant, we're going to go ahead and put the box. This is where our remainder goes. Keep that in mind. And we're going to bring down the first number 2. So bring this straight down. And then start your synthetic division. Okay, we're going to make 5 halves multiplied with 2. And the fast way to do this is take the 2, multiply it by the top, divide it by the bottom. So 2 times 5 is 10, divided by 2 is back to 5. Add the column and multiply. Add the column and multiply. So 8 times 5 is 40, divided by 2 is 20. And it's negative. Okay, and sometimes when you do this, 16 times 5, you might not know that really fast, so sometimes you can go backwards. If you times it by 5 and divide it by 2, well, that's the same thing as dividing it by 2 and timesing it by 5. Doesn't matter the order. The bottom is dividing, the top is multiplying. So I'm going to go backwards this time. 16 divided by 2 is 8. 8 times 5 makes 40, and it's -40. And then the box here becomes -52. This is my remainder. Okay, all right. Now, slightly different in this situation is that we now found synthetic division with a denominator. All right, so first thing we're going to do is recode but I'm going to show you that this is not the actual correct answer. Anytime you have a coefficient in front of your linear factor, you have to do one more step. And that is, first we're going to recode this. This is 2x to the third power, because it's one less than what we started with. This is 0x squared, because it's one less than the cube, so I don't have to write it. This is negative 8x's, and this is my constant. All right, we're going to pause for just a second on the remainder for just a second, but we are going to now take this, and anytime you have, again, this denominator where when you're doing a linear factor for synthetic division, you must divide everything by that denominator. So whatever that denominator is down there is what you're going to divide with. Okay, if that was a 4, then it would be divided by 4, etc. Okay, the nice thing about this is, and this is why we put the little box here, is that the remainder does not get divided out. Okay, the remainder is kind of shielded from the division of that denominator. So each term must divide out, so this is going to give us x squared minus 4x minus 8. And the remainder here will just be written as a fraction, negative 52 over what we were dividing with, which is 2x minus 5. And that becomes our solution. I want to pause right here, make sure everybody's okay, but I want you to go grab a calculator. And if you have done so, or if you have a calculator near you, then what I want you to do is go ahead and clear the calculator and go to y equals and type in this equation right here. Type in just the 2x to the fourth minus 5x cubed, etc. into y1. All right, and go ahead and do that. 2x to the fourth. Pause the video if you haven't done so yet. All right, hopefully now you have got that in, and I want you to go ahead and graph that equation. All right, and when you graph the equation, I want you to go second and calculate. And you're going to calculate an x value. So you're going to just hit enter on the first term that you see there. It says value. And when you do that, I want you to type in the root that we divided with. And we divided with the root 5 over 2. Okay, so you're going to type in on this value, x equals 5 over 2. And you're going to hit enter. All right, so again, second calc, hit enter on value, type in x equals 5 divided by 2. And you should see a y value pop up. It's going to say y equals negative 52. And if you notice, that's the answer for the remainder that we got. And this is very important to recognize. This is what's called the remainder theorem. The remainder theorem says you can do synthetic division, and the root that you use is your x value on the graph, and the remainder is your y value on the graph, and they create an xy ordered pair in the function that you are dividing with. Okay? So again, this is called the remainder theorem. It's very, very important to recognize that you can plug in, or you can do synthetic division with this x, and the remainder is the y on that graph. And I want to show you something, and that's very important. Scroll down to number 12 and 13. Number 12 and 13 ask you to use the remainder theorem to determine the value of f of 3. I'm going to show you real quick how we can do that. If you're doing f of 3, that means that x equals 3. So a long time ago, Algebra 1, you probably came over here and were thinking, oh, I got to plug in 3 cubed minus 3 squared minus 5 times 3 plus 3. And that's correct. You can do that to find whatever that answer is. But you can also do synthetic division with the number 3. So I'm going to come over here. I'm going to type in my synthetic division. 1, negative 1, negative 5, and 3, and put in my box. And my answer for this is going to be right here in this remainder. Okay? Bring down the 1, multiply, add, multiply, add, multiply, add. So this means that f of 3, when I plug x as 3, my answer has to be immediately 6, and I'm done. And that's a lot faster than sometimes doing all of this math up here or going to a graphing calculator. Okay? All right. Everything looks good. I want you to be able to finish this page. Let's talk about number 9 real quick. If you know that you have a function, and I ask you to find a factor, from yesterday we said that the factor happens when you have a remainder of 0. Well, you can tell that with the table because the remainder is the y value. All right, so here's my y values. Let's see. Right here is a 0. So this right here, x equals 1, x equals 1 must be a factor. So the factor turns into x minus 1. And what we're going to do is we're going to completely factor this problem out. So to do that, the easiest thing to do is we know we have a cubic equation because that's my leading power. That is my degree. And that tells me I must have 3 factors. Well, here's one of the factors right now. All right, so to find the other 2, we can take out the first factor and then go from there. So what I'm going to do is I'm going to say, all right, I'm going to linear Synthetic